Hello everyone. The title of this video is Identifying the Degree and Leading Coefficient of a Polynomial Function. Alright, so every example I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 5.2, called Power Functions and Polynomial Functions, and I'm under the heading Identifying the Degree and Leading Coefficient of a Polynomial Function. Alright, so each example is going to be taken directly from this text. It's going to be an example from the reading, or a try-it problem from the reading, or one of the exercises at the end of the section related to this particular objective. Alright, so before I get into this first example here, I want to refresh your memory from the previous video. I wrote this page out in the last video on identifying polynomial functions. Remember what a polynomial function is, right? It's the sum of power functions whose powers are whole numbers, right? So no negative powers on the variable, no fraction powers on the variable, and meaning it can be written in this form here. F of x equals a sub a, a number times x to the nth plus a number times x to the n minus 1 right, plus a number times x to the first, and then plus a constant, a sub 0, a constant term with no variable, or you could say x to the 0. All right, well, what we're doing in this video is, they're going to have me identify the degree, the leading term, and the leading coefficient of a polynomial function. So first I'm going to write it in this general form here. Alright, first I'm going to write it in this general form, and the highest powered term, this term right here, that's called the leading term. Alright, and again, it's the one with the highest power on the exponent, on the variable x to the nth, right? You see, then you have n minus 1, which is smaller, and then you keep decreasing the power by 1. And then the number that's part of that term, the numerical factor, right? This a sub n times x to the nth, the number multiplied by the x to the power, that's the leading coefficient. And then finally, the degree of a polynomial is simply the degree of that leading term. Now the degree is simply, for these one variable polynomials, is just the power. So the exponent, right, the power on that variable in the leading term, that's called the degree of the polynomial. Okay. So again, first thing I'm going to do is I'm going to try writing, if I'm given a polynomial function, I should be able to write it this way. Highest power to constant term, highest power to lowest power. And then once I've done that, it should be easy to identify the leading term, the leading coefficient, and the degree of the polynomial. All right? Great. All right, so the first example here, they give us a polynomial function, right? And you see all these power functions being added up. There's 4 terms, and every single one of them has a number times x to a power, a whole number power, right? Not a negative power or a fraction power. And we're asked to identify, the degree, the leading term, and leading coefficient. Okay, now first off, this is not in general form. All right, this isn't in that form that I showed you on the previous page. And why is that? Well, not in general form because general form for a polynomial function, starts with the highest powered term and then goes down by the powers. So if I'm writing this in general form, the highest powered term is negative x to the sixth. Right, if you look at all the powers on the variables in each of these terms. The next highest is the positive 4x squared, so plus 4x squared. The next highest term is, the positive 2x, and then the constant term, the lowest powered term, is negative 6. Right? So this is in general form for a polynomial function, right? In descending order, they would say. Descending order, highest power to lowest power. All right, so now that I know this, got it in that form, we can very easily identify the leading term is just the highest powered term, right? So the leading term of this polynomial function is this negative 1 times x to the sixth. Right, and then the leading coefficient is simply the coefficient of this term, this highest powered term, which is negative 1. I know the 1's not there, but you could write it in if you wanted. But the leading coefficient is negative 1, right? Just the coefficient of the leading term. And then finally, the degree. The degree of this polynomial is just the degree of the leading term. And then with a single variable here, all you need to do is say what's the power on that leading term. This would be called a 6th degree polynomial. Right? This is a 6th degree polynomial. And there we go. That is it. That is all we are asked to do, in these exercises. All right, and this will be important for the next video when we talk about the end behavior of a polynomial function. If you can identify the leading coefficient and the degree of the polynomial, you're going to be able to say what happens on the far right and far left to the function pretty easily. All right, so next example. Now the next example is real simple. There's only a single term in it, a single power function, right, with a whole number power. So it's very obvious that the leading term, right, is the only term in the polynomial, this negative 3 times x to the fourth. And then again, pretty obvious that the leading coefficient is just the coefficient of this term, which is negative 3, right, the numerical part. And the degree of this polynomial, again, is just the power on the variable in that leading term, is 4, right? This would be called a 4th degree polynomial, sometimes referred to as a quartic. Quartic for 4th degree polynomial. But that's it. Right. That is all we are asked to identify here. Great, and I just got a couple more of these. These are pretty simple, I feel. Just got to make sure you know what the highest powered term is. That's all, the leading term. All right, so this one here I'm going to write in general form, right? It's not in general form right now because the highest powered term's not in the lead. So if you were to rewrite this in general form, the negative 3x to the fifth, right, that would go first. Then the minus 2x squared term, then the positive 1x term, and then the negative 6 constant term. Right there's the polynomial in general form. It's still the same polynomial, right? Just the terms are reordered, so it's in descending order. And then I'm hoping it's obvious now that I have it in descending order here that the lead term is this negative 3x to the fifth. All right, so the leading term, negative 3x to the fifth. The leading coefficient, again, very easy once you identify the leading term, is just the numerical factor in that term, that leading term, which is -3. And then finally, the degree of this polynomial is again just the power on the variable in that leading term, which would be 5. So this is a 5th degree polynomial. Now, a 5th degree sometimes is referred to as a quintic polynomial. Right? And I guess I could have written up for the first example, a degree 6 is called a sextic or a hextic. Whatever. Right? You're not going to really need to know the names. Right? Just say it's a degree 5 polynomial, and I'd be happy with that. All right, and I've got just one more of these. Now, this one definitely is not written in that general form. For this one, I have to do some multiplication. Right? If I want to get it in this form, where it's just a sum of power functions with whole number powers, I need to do some multiplying here. So this is x squared times, now 2x minus 3 squared. That would be 2x minus 3, times 2x minus 3, and then you FOIL and all that. Well, if I do that and combine like terms, I'll have 4x squared, and then minus 6x minus another 6x, so minus 12x, and then plus 9. So 4x squared minus 12x plus 9 is the product of 2x minus 3 with itself. And then I need to just distribute the x squared here, and we'll have our polynomial function in that general form. Be 4x to the 4th minus 12x cubed, and then plus 9x squared. And the powers are in descending order. There we go. So now that it's in that general form, it's very easy to determine what they want us to find. The leading term is 4x to the 4th. Then the leading coefficient is positive 4, just the coefficient of that term, the number times that x to the 4th. And the degree is, again, just the power on the variable in that leading term, is 4. And a name for a degree 4 I mentioned earlier was a quartic polynomial, And a degree 3 would be a cubic, a degree 2 would be a quadratic, a degree 1 would be a linear, a degree 0 would be a constant, and that's it. That's as low as you can go, as degree 0, because there's no negative powers, No negative powers, no fraction powers for these polynomials. It's all whole number powers. And I'll box that in. That's all they wanted, and that's it. Like I said, these are pretty simple in my opinion. You should be able to multiply polynomials, write it in that general form in descending order. And once you've done that, identifying the lead term, the lead coefficient, and the degree should be simple. And I'm hoping that watching me go over these 4 examples here, help you in some way when you're asked to do this, identifying the degree and leading term and leading coefficient yourself. And thank you very much for watching.